Alright, hi guys, today we're looking at graphing rational functions. The first thing that you need to understand and recognize is that to graph a rational function, in reality, what you really need to do is make a table of values and use that to plot the points that create the function. The only thing you need to recognize when you're close to a vertical asymptote, you have to use more points to get a better view of the picture. But what we're going to be doing today in terms of discussing graphing rational function is a way to come up with a fairly accurate sketch of the graph. A way to kind of figure out this is a really good picture of what the graph should look like without so much need of a calculator to try and help you figure out and understand what's happening. So this right here, so we do this with an example, and so we will use the function f of x is equals to 3x squared minus 3x divided by x squared minus 16. So this is the graph that I'm trying to graph right here. The first thing that we're going to do is we're going to go ahead and get all the properties of the graph that we have done before. And so the first thing we need right here is the domain. And that is you would set the denominator not equal to 0. Distinct factor is x minus 4, x plus 4 cannot be 0. So x cannot be negative 4, x cannot be 4. Right here, x such that x cannot be negative 4, x cannot be 4. That's the first thing you find right here, the domain. Next thing you do is find the vertical asymptotes. To find the vertical asymptotes, you first have to factor the problem. So 3x over x squared minus 16. That becomes factor of 3x, and that's x minus 1 over x minus 4 times x plus 4. Now, what would you do? What you would do is that if there were any like factors, you would cancel out those like factors and reuse the reduced function for the rest of the problem. So you have to use the reduced function for all the remaining steps. But this one doesn't cancel, so there's just something to note. The reduced fraction is always simpler, so it makes any calculations that you do simpler. The only thing that the domain uses always uses the complete function, not the reduced function. But anyway, this doesn't reduce. So to find the vertical asymptotes, which is step number 2, you set the denominator not equal to 0, x minus 4, x plus 4 equals 0. So x equals 4, x equals negative 4, and those are my two vertical asymptotes. Step number 3 is to find the horizontal asymptote. So step number 3, find the HA, and in this case right here, my horizontal asymptote will be to divide the two leading terms, the two dominating terms, and so my HA will be y is equals to 3. Step number 4 is to find the y-intercept. Let me rewrite the problem. 3x times x minus 1 divided by x minus 4, x plus 4. So to find the y-intercept, you plug in 0. So you plug in x equals 0, and then when you plug in x equals 0, you get 0 divided by negative 16, which is equals to 0. So the y-intercept is 0, comma 0. Which, by the way, tells us that one of the x-intercepts will also be 0, comma 0. the origin is the only double intercept. It's automatically both your x and your y intercepts, which I always find interesting. Don't you? Step number 5, find the x-intercepts. And so to find the x-intercepts, you set the equation equal to 0, or simply the numerator. So 3x times x minus 1 equals 0. And so 3x equals 0, so x equals 0. And then x minus 1 equals 0, so x equals negative 1. X-intercepts, x-intercepts. So those are the 5 properties. Remember, to find the range, you actually need to graph the function first. And so that's actually what we'll be looking at. And that's the last thing we will find, is the range of the function. And now, what we have to do is some analysis on that function. Now that I have all of this information right here, I need to do some analysis on the function. So, I have my axes right here. I know my vertical asymptotes are negative 4 and 4, so negative 4 vertical asymptote. So VA x equals negative 4. At 4, I have a second vertical asymptote. VAX equals 4. I have a horizontal asymptote of 3. So at 3, I have a horizontal asymptote going across right here. So that's my HA y equals 3. And then, excuse me, and then I have, what else do I have? I have the x-intercepts and the y-intercept at 0, 0. And then I have the second x-intercept at negative 1. Like so. And so, what I'm going to do right now is I'm going to try to figure out where the graph is. Is the graph below or is the graph above the x-axis at certain points? So what I'm going to go off to the side is I'm going to go off to the side right here. I'm going to draw a little number line. And I'm going to put on this number line the key points. The key points are your domain values and your x-intercepts. And so my domain values are negative 4 and 4. And then I have my x values at negative 1 and 0. What I'm going to do is I'm going to try and figure out what's the graph doing in each of these sections right here. So, let's take a number from this section right here, a test point of negative 5. And so I'm going to take negative 5, I'm going to plug it into the function. So I'm going to take negative 5 and plug it into the function. When you plug negative 5 into the function, you will need a calculator to do this. So, useful to have one. And so 3 times negative 5 times negative 5 minus 1 divided by negative 5 minus 4 times negative 5 plus 4. And that gives us an answer of 10. So when I plug in negative 5 right here, I get the coordinates of negative 5, 10. And so that's a point somewhere up here. Negative 5, 10 is right there. I need a number between negative 4 and negative 1, say test point of negative 3. So I plug my negative 3 in. When I plug in my negative 3, I get negative 5 approximately. So negative 3 comma negative 5. Number between here and here, test point of negative 0.5. So I plug that in. I'm rounding to the nearest whole number, just to let you know. Negative 0.5. Plug that in, I get an answer of negative 0.1. I needed some more accuracy. Negative 0.5 comma negative 0.1. And then a number between 0 and 4. Let's take 3. So test point of 3. And so with that 3, I plug 3 in, I get negative 2.5. So I plug in 3, I get negative 2.6. And then number larger than 4, let's type 5, so a test point of 5. Now you get the idea right here, that graphing these things right here are a little bit more difficult because of the complexity of the functions. You guys gotta take your time, make sure you plug these things carefully into your calculator. And when I plug in 5, I get 5.67. So back to my graph over here that I'm trying to draw desperately. So this is point right here is negative 1. When I plugged in negative 3, I got negative 5. So negative 3, negative 5, that's a point down here. You can see the point coming in right here. Then I got my negative 1, then negative 0.5 comma negative 0.5 should have been positive right here. And then when I plugged in 3, I got negative 2.6, so I plug in 3 over here. And then when I plug in 5, I got 5.6, which is. So how does all of these points that we have right here help us get to our answer? Well, what happens is that we know that the graph will bend around the asymptotes, generally speaking, except when they're between the vertical asymptotes. So this first point over here shows me that the graph right here will do something like this. It will get stuck between the two vertical asymptotes, the horizontal and vertical asymptote. And so this right here will be the first branch of the graph right here. The middle piece right here, the graph starts negative, again hugging the vertical asymptote, climbing, and then coming on backwards right here. It doesn't have to get to the horizontal asymptote. And then it will come on back down right here. And then again it will hug the vertical asymptote. Again, it will not be able to pass the vertical asymptote. The vertical asymptote represents a clean break in the graph. And then this last point up here, again the graph will come on down. Again the horizontal asymptote will start taking effect again. And then the vertical asymptote, it can't get past the vertical asymptote. So all of these right here give us the picture of the graph. If I wanted to get a better picture, like I was saying earlier on, all I would need to do is get more points. And so that would just mean more work on the calculator, finding more points that give us the exact position of each of those right here in the graph. Alright, that's how you graph a rational function.